thank you for everybody who's here for the EN-LoTIS Town Hall meeting. And if more folks trickle in, that'd be great too. Thanks very much for the working group members who are here. And could you just raise your hands if you're in the EN-LoTIS working group? So a few people. Okay. Wonderful. And a couple I haven't met before, so I'll have to. Hey, here. Okay. I was hoping this would be a good introduction to folks who haven't been involved in the working group yet. So just very quickly, here's the membership of the working group. Half from the US, half from Europe. This is a joint ESA-NASA working group to study mission concepts related to a low-flying or a dipper type of mission. I'll give some programmatic context later. Essentially, it's not a new concept. It's one that's been around for a while, but for various reasons, both NASA and ESA would very much like to work together on trying to make something like this happen. I think the time is now for starting the planning for this. So essentially, we want to explore in situ observations that can be carried out in the 100 to 200 kilometer altitude region. And so the work here is basically we sort of have an initial 12-month timeline. And at the end of that 12 months, we'd like to have a report that we could make available to the agencies, NASA and ESA, and to the public, talking about the high-level science goals and objectives of this mission, and maybe some of the getting into some of the very early concept and design stages, without getting into a detailed technical study. And basically, because we've got some timelines that we'd like to align with in terms of programmatics, we anticipate an interim, hopefully 6-month report, and then a final 12-month report, starting basically from now. So the 6-month report could be due in the December timeframe, and the 12-month report maybe in the late May timeframe if we're really motivated. So thanks for everybody who's here. Thanks for everybody who applied for membership. We couldn't select everyone just from we had to limit the number of people involved just for programmatic reasons. But one of the reasons we're here today is to get input from the community and talk about this activity. This is a slide. It's a very busy slide. Lex Hoffman provided, giving some programmatic context from the European Space Agency's point of view. I'm just wondering, is it possible, hey, the folks back there, is it possible to turn these lights down or off, just so we can see the slides a little better? Just the ones in front would be great. Oh, yeah, super. That'll work. Thank you. Essentially, this is building off of a big project which many folks in this room have already been involved with, which was the Daedalus concept, which was a suite of instruments on a low-flying ton-class spacecraft that was proposed. It made it through what I guess they call their phase 0, which is sort of akin to our phase A concept study, but it was not selected. Just as a sort of interesting tidbit, so to speak, in the European Space Agency, the extent of the Earth observing program, which this Daedalus concept was submitted to and evaluated by, they go up through the ionosphere, or at least the lower ionosphere, sort of Thermosphere-Ionosphere. So they don't have this division like Earth sciences and heliophysics at NASA, where they stop, one stops and the other starts. And so this was an Earth observing program mission. And that's important because one of the things they wanted to do was work very hard to tie in not only the ionospheric and thermospheric aspect, but connect to the lower atmosphere. And this was one of the reasons why they focused a lot on, push the wrong button. Effects, for example, of precipitating energetic particles and the Higgs-Knox chemistry going down into the stratosphere. So for various reasons, basically, from what I understand, this was a very ambitious project, and ambitious translates into very big and very expensive, and they just couldn't support it, the selection of it. So the idea is together, taking some of these concepts, NASA and ESA could combine and perhaps put together what we would call a strategic mission, or what the Europeans actually call a mission of opportunity. Their missions of opportunity are not the same as ours, but essentially a directed mission to try and address some of these key science goals, which are listed here and include a better understanding of really just the transition region. That's 120 to 200 kilometer with in situ measurements. You have the opportunity to take some basically deep dives into the E region, measuring key parameters. We'll talk a little bit more about that in a second, but essentially anything you need to do to sort of close the loop, so to speak, on the energetics and dynamics going on in this lower atmospheric region, you know, getting handle on the things like joule heating, and the sort of the key things that we still really need to tie together with simultaneous in situ measurements. So the idea is, again, from the ESA point of view, is this mission was not selected. They actually did quite a bit of work developing two different types of concepts from two different groups. This is sort of a mock-up of what it might have looked like, and you know, they had done a lot of engineering studies even and things like that. We'd like to sort of keep the momentum going forward on that. So I think from our perspective, what we'd like to do is there was a ton of work done on the dataless proposal, and it'd be a shame to let it go to waste. And so if some of this can be taken and transferred into a sort of a joint agency mission concept, that would be, I think, great for the field and for just the science in general. So that's sort of the programmatic concept from the ESA side of things, as best as I can try and describe. From the NASA side of things, again, the famous HSO plot, and there was a lot of talk, and will be a lot of talk about GDC and dynamic. Everything we're talking about here is not to replace or to supplement, or I mean, not replace or displace any of these things. As it was explained to me over a year ago, when this idea of the working group was introduced to me, was that a directed mission to do this sort of thing jointly with ESA would complement GDC and dynamic. It would not compete, but complement. And again, from what I understand, it's still GDC, for example, the spacecraft altitudes will be higher. I think they'll be taking mostly in situ measurements. We really, it sort of goes back again to this maybe bad analogy, but in supply chain, it's that last mile. How do you get to that, you know, your product to that last mile to where it needs to be delivered? And in our context, what's those last 100 kilometers, 150, you know, what's going on in there? We can't just have, you know, a fudge factor of, you know, oh, you have to scale everything in your model by 0.8 because that's the only way it works. Well, you know, maybe we could have some measurements or things to confirm exactly what these key terms in the energy for the ionosphere and the neutral interactions. So this is just sort of in a very broad base what we'd like to do in terms of joining ESA and NASA together, and this is sort of the background or the context for that. I mentioned the timing a little bit. To be perfectly honest, we put this working group together from my point of view sort of backwards, you know, where we probably would have put a little bit more planning in on the front end, except we had some pretty tight timelines, and I'm going to try and address those here. Unfortunately, this doesn't show up too well, but so I'll try and read. But Essentially, when we started in late 2021, it was recognized that there was a couple of big things that go on that decide how the agencies will plan and budget for a strategic mission. From the ESA point of view, it's what they call their ministerial conference. ESA is a bunch of countries. They get together. They talk about how a lot of different, there's a lot of moving parts. How do you get them all to decide on what they're going to contribute and fund to for the next, several years or decade even? Well, these ministerial conferences are one way they do it. And this sort of sets in motion their planning. And there's going to be a ministerial conference in late 2022 here, but they have to finalize a lot of their content here, which is right about now. And if there was ever going to be talk of a joint NASA-ESA project, they had to say, okay, this is happening, people are talking, things are getting done. So this is sort of why now we're meeting, and we're going to, and the EN-LoTIS working group members from the U.S. will start talking and working in close collaboration with the European members starting now, so that from just a programmatic point of view, they can say, yeah, we're working on it, we're doing it. Both agencies are committed to this, and B, by the time we get this. Hopefully maybe a draft report of some of the objectives of this group, that'll be in time for this ministerial conference. So that's maybe a little bit more politics than science, but that's my understanding of it. At the same time, there's a lot of talk about the decadal process. Now, we may have actually been, I don't know if helped is the right word, but we thought maybe that the announcement for the white papers was going to come out in May or something like that. Now it's later, and I'm not going to comment too much more on that, except, again, the science, the need from the community for really determining these observations in situ, 100 to 200 kilometer region, closure of some of the energetics and some of the big open questions that can be addressed with this type of a mission. Getting that into the decadal is going to be important. Now, I can't tell you what to put in the decadal survey. The working group is not writing white papers, but we can communicate with the community can communicate with the working group, all by way of saying this type of support and input into the decadal survey would help. And again, that's the timing for this stuff. And it wouldn't necessarily displace other things. I think, again, it would add to and also make the case for there's still some really critical things that we need to address. And a directed mission or some kind of mission with a low flying or in situ aspect could do that. So I think that's all I'm going to say about that, except what we'd like to do, if possible, is whenever we have a big meeting like CEDAR or AGU or EGU or other workshops, there's an ICE-SCAT workshop in August, I think, for the incoherent scatter radar community. We want to talk about EN-LoTIS there. We want to maybe get some input from the community, and this isn't a closed process. This should be an open process as much as possible. And so the working group is going to meet quarterly to sort of have sort of some dedicated time, as I also talk a little bit about putting together a report that will be sort of like an overview of the scientific objectives and goals for such a mission that'll help sort of begin the steps of planning and formulating perhaps this kind of mission. So there'll be quarterly meetings. If we can time them around the big meetings, that would be great. And I think that's all I was going to say about the timeline. I don't want to, except I guess that red square is sort of the lifetime of the initial 12 months of the working group as we envision it. And I'll just, as I reminded myself here, As we approach, the end of this 12-month timeline, we'll probably evaluate and see where we are, and hopefully maybe continue this and maybe even expand the working group's membership and also its scope, maybe to take in more of the technical and some other, maybe more instrument-specific aspects of the planning. But for now, we're sort of, this is sort of the plan for the first 12 months. Just again, as I mentioned, and the people in the audience, and I'm looking at Rob, obviously, and other folks who were involved in Daedalus. This isn't a new concept, having these low-flying missions, but it's been a long, long time since we've ever had one. And again, that's why I think, given the state of where we are with the science, with the modeling capabilities, with the needs of the community, it is, again, really time to address this, or long past time. So starting from the AE Explorer missions, the proposed timed and GEC concepts, and others through to Daedalus. I think it's hopefully together NASA and ESA can sort of push us over the barriers that we've been running into. So what this working group is going to do is review and consolidate consensus science questions and goals and mission objectives and high-level mission requirements that would inform the eventual definition and design of concept study. We're not starting from a blank slate. Just as I showed, there's been a lot of proposals, a lot of work, a lot of effort to develop this over the years. And so the degree to which this group can leverage knowledge from these past and current missions, Daedalus, obviously, would be key. And we also want feedback from the community. And as I've often said, for this initial phase of the working group, at the end of 12 months, what we would like is something like a science definition team report. So not a full STDT. I always have problems with that. So it's not the science and technical, it's just for right now the science definition team. And identify, now you can't unwrap all the science, you can't, the science and the technical stuff is to some of the constraints on just what the mission would look like are kind of entangled. So we're going to have to sort of figure out how to deal with that as we go. But really, we want to sort of balance the science and the feasibility and look at trade-offs and maybe talk and develop it for this working group, determining, in a sort of a naive way, how low should we go to do the science, and how low could we go or can we go, and still make this a viable mission. I think perhaps the idea was that with the Daedalus concept, it may have, I think mission creep might have been some of the what I heard, or is it just it got big and it got complicated, and so maybe one of the things would be to figure out some of these trade-offs, balancing the science and the feasibility. I think that's pretty much it. I've got some questions that have arisen just between discussions with myself and Lex Hoffman, who is the ESA point of contact for that. We could go over these, but what I prefer to do is just stop talking and have other people chime in. And I will mention that we don't have a website yet, so the best thing for some information would be to go here, which is basically just the call for the working group, which many of you may have seen already. But what I'd like to do is try to get something set up soon. In the meantime, I'm the main NASA point of contact. Lex Hoffman is the main ESA point of contact. If you're interested in this activity and want to know more, please email me. And that's it. So at this point, I guess I don't have any more need for the slides. Would it be possible to put the lights back on? Thanks. And I don't know, feel free to, anybody here, raise your hand, ask questions, tell me it's a great idea, horrible idea. There is a microphone behind you, though. I don't know if you want to do that.
So I didn't get a chance to look at the working group membership, but how much are you guys learning from Maven? I mean, do you have Maven people on your team? Is there a Maven connection? Because that was maybe missing from your as flown missions, not at Earth, but a lot of lessons learned there, I think.
See if I can look back. That's a good question. I don't know, just because Maven sort of predates.
So I was on a data loss science team, and then was disappointing that wasn't selected. But then there are lots of questions came up, and then I think one thing is those, if the reviews documents could be made available, that would be very helpful. I think it is. But so Maven, I think what I saw is like there are lots of contamination on the outlet portion of Maven data. And then, well, this is smiling. And that's something that, like, it actually exists in data, and that's really, they're still sorting out to. Yeah, but there's also, great stuff. Yeah. The other thing I wanted to say is I think I probably, you said it, but are you thinking of AGU town hall meeting type of thing to gather more?
I mean, that would be good. To be honest, I haven't, aside from trying to meet around AGU with the working group, but whether it's a session, whether it's a town, I mean, it's probably too late for a session. But yeah, we should, if we could arrange something like that, and yeah, we should probably start thinking about that sooner rather than later. But I think that would be great.
So, I mean, that all sounds exciting, but I mean, I'm actually a little concerned when I hear that this is more kind of another strategic priority mission, kind of decadal survey size of mission. I mean, given the sorry state of dynamic and possibly of GDC, I mean, at some point, it feels like we should actually do what the community already agreed upon many years ago and pushed for that again and again and again. So I don't want to be too negative also. I mean, there's certainly exciting science here involved, but I'm a little bit concerned that we perhaps overstretching ourselves a little bit. That's so just as a thought that I want to voice here.
And I agree. I see other hands raised, but because this is NASA and ESA together, I don't think it necessarily, certainly it's not going to be on NASA to bear all the cost. And I think, part of this working group too can be to think about different and more creative ways to do this. It doesn't have to be a huge directed mission, or for example, and don't quote, but one thing is, perhaps ESA could take the lead with the spacecraft and NASA could provide instruments or something. Again, I totally hear what you're saying about the GDC dynamic. It is not our intention to displace or otherwise sort of replace, hopefully complement, but I see Rob's ready to go, so.
Yeah, I also echo that we do not want to do anything that's going to inhibit GDC or dynamic. No question. In fact, right before we started, I came up to John and said, should we even put in white papers on EN-LoTIS, because we don't want to send any message that we don't want GDC to happen. The reality is, and dynamic, the reality is this one still is in the future. Believe me, I've been around. This is not going to happen tomorrow, and it's not going to circumvent or impede GDC or dynamic. But we want to make sure of that. Now, I have to just make a historical comment. If you could just go back a slide or two.
Sure.
I'll tell you when. Go back to the one with the NASA missions. Another one. That one, stop. Oh, it's almost painful to say this, but I just want to say that 2 decades ago, we had GEC, 4 satellites going down to 130. It just vanished. The way we don't want GDC to vanish, by the way. So we already had and the community said, finish what you agreed on. And we'd agreed on GEC. It just, George Withrow, Dick Fisher, whoever just decided, I don't hear the call or whatever. There's some funding problems, and so they didn't go forward with it. So that's exactly the same thing you were saying. Also, time had 2 dippers. We already made those science arguments. Those vanished. And so, we're trying to, this important science, that's why we're here, but we're not by any means trying to take over for GDC or dynamic, by no means whatsoever. We're here because we identified great science on these before, so have the Europeans. So having a working group, getting the process going on this is, I think, why we're here.
Yes. And I mean, I can't speak for the European Space Agency, obviously, but this is something they're very interested in. This is something that the timing of this and getting it into their long-range planning, because there was a lot of work and a lot of support for the dataless concept, and I think they just don't want to see it die on the vine, so to speak. And so, but again, the only other thing I could say is, in terms of planning, yes, this is late this decade at the earliest, so to speak. People like Larry Kepko says, if you give us the money, we can put it up in 2 years or something like that, but that's Larry.
I just wanted to draw a parallel with this timeline and what was done with Solar Probe. Solar Probe, it was the same sort of history here. Everyone wanted to do it, pounding on the table for years, for decades. It finally flew. And maybe we can take a page out of their playbook and add European support, and maybe we don't have to pound on the table for quite as many decades as they had to.
I mean, I think Solar Orbiter is a great example too. The Solar Group does this all the time. Solar Probe, $1 billion mission. Let's enhance it by adding Solar Orbiter. Let's enhance it by adding IRIS. Let's enhance it by adding Punch. We shouldn't be shy of that. I think other groups will do it for sure. Well, just that's all I have to say. I think partnering with Japanese groups, with European groups, we want to leverage their investment, leverage our investment, and make a bigger pie for everyone, and not be competing amongst our missions. We're here to decide. Yeah.
So I think one question that sort of resonates with me with some of these samples up here is, how can we effectively gather input from the community for this? We can talk about it. You can ask questions. I can write down and say, okay, they asked this and they asked that. I don't know. I think maybe this is something we could think about for the working group, as well as what would be some of the good means to collect some of this stuff. I don't know if letters or surveys or some sort of more formal communication with groups like CEDAR or other things are warranted. But again, maybe we could think about that. Like I said, we would like to align as much as possible with conferences and workshops over the next 12 months as this working group gets cooking and rolling along. And I think the other thing is, this isn't just an instrument exercise or space. This isn't just observations. There's one of the things that was really emphasized in the ESA proposal for dataless was that this is a system-wide approach that tries to take the best advantage and the best use, and is informed and will inform the modeling and the data, sort of the, how do you best use all this data? I'm trying to remember now, they have this term, they call it the digital twin. I don't know if anybody's heard that. It's sort of, I didn't understand it at first, but essentially it's like, what is the Earth system in computer models? How is it represented? That's sort of the digital twin of the real coupled system, and it's not just, a box that starts at one altitude and ends at another. And so I do, I really hope we get some good input from the modeling perspective on what's needed, what works, what doesn't. I mean, one of the reasons Astrid is on this working group is we know she's got a lot of experience in there, but it's not just the people in the working group. So I think I'm hoping we can have some good discussions and good input that goes just beyond what types of instruments and what types of spacecraft and what types of orbits, but getting into what are the challenges for modeling, what are the approaches for data assimilation, data fusion, that sort of thing. Again, that's just sort of my 2 cents. I didn't want to leave that unspoken, but is there any other? I would definitely welcome anybody who's got any sort of opinions. Contribute. Yeah.
John, do you want to speak to ground-based synergy? Because this is a CEDAR community, the people who have their own instruments, and then if common volume.
I don't want to get beat up about how, crossing boundaries or anything. Clearly, though, as I tried to say this morning, and I've always said, the combination of ground-based and space-based is really important for the ITM. And it's not about it's about where the science is. It's not about where the platform is, or, it's what do you need to understand this complicated region of if you want, geospace. I think there's a lot of opportunity, and especially because we are in these early planning stages, the very earliest planning stages. Whatever input, whatever support or synergies, I don't know what you want to call it, collaborations with ground-based, that's going to be key. Because again, I think it'll make a stronger case for doing this, because it is, we are targeting a fairly narrow region, and we are targeting, I think, a very important, but, from a programmatic point of view, people could say, well, why are you just focusing on this tiny little area? Well, it's a really important area, and it's an important area that you've got to attack from a bunch of different angles. So I'm talking a lot, but yes, any kind of input, any kind of working with the ground-based communities. Again, like I mentioned, we'd like to have somebody from the European membership was going to go to the ISCAT workshop and have this discussion. If there's other ones, if there's other, yeah, Doug, I'm sorry.
Is not now? Okay, yeah. I can add a couple of points. Tomorrow at this time we will have a town hall on the future of ground-based instrumentation, with the goal of having communication between community and NSF, and encouraging again decadal survey white papers. And there is a lot of development, ongoing development, and depending on what can be funded and will be funded, a lot of interesting things can be implemented in the MLT region. We have outstanding development, outstanding features that we can see in a new type of meteor radar data. We can talk to this guy. knows all about it. And this type of concept is implemented and will be implemented, but it's already funded. Projects are ongoing to have such systems in continental United States. People have interesting concepts about LiDARs. And with LiDARs, we can go now all the way to 300 kilometers. Also, all the way from mesosphere to 300 kilometers under certain conditions, depending on what investments are possible. You know, we can have ground-based. People talk about different concepts, networks of cheaper instrumentations to have broad coverage and go after large-scale regional phenomena, large-scale phenomena, and combined with clusters, with hubs that have multiple instruments where you can go after in-depth science of when you have observations of multiple parameters at the same time and in a large altitude region. All these things, all these concepts are discussed, and I think we will see within next several years what actually will be implemented, what will be funded. And you saw today when NSF presented facilities, we talked only about 4 incoherent scatter radars, right? And the state of them. At the same time, we know that iSCAT 3D is a huge investment. It will be outstanding science. So this is what Europe is putting in the money. I don't think we saw at this meeting anything about Chinese incoherent scatter radar. A lot of money was put into it, a lot of effort. Results are mind-boggling. You know, it's something. So this is what you do if you results, what you can see, what you can achieve if you put some money into development at the cost which is maybe 50 times cheaper than for NASA. So I think this is a good time and place to talk about it. But again, I think that we keep talking about more and more communication, encouraging communication between NASA and NSF so that we can leverage all of this. Every scientist in the room will say, yes, we need to leverage this. We need to leverage all the resources that we can do best science possible. We just need to figure out how to do it.
Okay. And if you could work in a plug for our working group in your session tomorrow, that'd be great.
I want to make another, I'm sorry.
Okay. I do also just want to be conscious of the time because does the session start up again at 1:30 or? Okay, so we probably have at most about 5 more minutes.
Okay, I want to make sure there's no one who has a burning question or comment. But I just want to get back to the charge of the working group and what I see as our biggest challenge. You asked us to talk just about science and not technology, but therein lies the problem, in my opinion. And the Hall conductivity, Hall mobility peaks at 105 kilometers. Pedersen may be 115 or something. So everyone wants to get down there, into the electrojet, whatever. It just isn't, I don't want to say it's not possible, but it's a huge challenge to get down below 120 kilometers. And I think this is how Daedalus stumbled. I was on the advisory group, and you had spirited co-eyes telling, let's go to 110. And somebody even invoked John Kennedy and said, we're going there to the E region because it's hard. You know, it's important, and not because it's easy. And sure, everyone got all excited. But the reality is, if you want to really go all the way down, it's going to take a lot more money, a lot more propulsion, new instruments. I mean, so I personally believe we should have a precursor mission, sort of like an Explorer. It doesn't have to be an Explorer. You know, where we can just go to 130 or something and just test things out. You know, Maven was great, and we could do analogies, but Maven, the atmosphere is not nearly as dense as on the Earth. And I think when we did the Dipper Explorer, we put 120. And Temco said, oh, you're going too low. We don't like, this panel at NASA, you know, the risk is too high. And we put 120 because time was going to 120. We wanted to mirror that. We wanted to recover the time science. So then GEC went to 130, and we backed off on our Astro Explorer to 150 to just say we can definitely do this. And then we had all this margin. We intended to go lower, but we came up with science that we could do, new science to just go into 150. The science does get so much better if you go lower. I personally think that we can do so much if we went, say, to 130. We should be realistic. And I'm worried the working group is going to just come back and say, let's go to the mesopause, 90 kilometers, all this, so we have to have some limits. And the best analogy, in my opinion, is solar probe, Parker Solar Probe. Originally, that was going to go to 4 solar radii. It's now going to 9 solar radii, and it's doing great stuff. And I'm sure, why not go to 1 solar radii? I mean, there has to be some sort of technical, we have to throttle back and be realistic. This won't be the only mission we're ever going to have that's going to dip. So I really think we should come up with great science, do just what we're doing, and have something that's very doable, and not try to be too ambitious, even though I don't want anyone to think I'm not forward-looking or something. Yeah.
Also, I don't want to just keep talking, but I guess the thing I would want to say if I was the decadal survey, they're not ITM people. They're not the people in this room who are so excited about it. They blink, they squint, and as Jens said, we've got GDC, dynamic, this. What's the big picture? How do I differentiate those missions? So I think it'd be very helpful for us to come up with some white papers that kind of lay out a cohesive plan that says, okay, we're going to be using ground-based to study this and this to study this, and GDC does this part of the problem, and dynamic does this part of the problem, and EN-LoTIS does this part of the problem, and show that they're very distinct and that we have not 10 different people wanting to do 10 different things. We have a community that wants to do all of those 10 things because they're all important to do our job. And I think laying that out, without that, they're just going to look at this, another mission the ITM guys want. They already got GDC and gold and dynamic, and I'll forget it. So I think laying out that strategy would be important.
Thanks very much, Doug. I think we need to wrap up, but any final thoughts, comments? Okay. Well, I'd like to thank everybody for your participation and attendance and giving up some of the precious lunchtime hours. Thanks again. And again, my email's here on this slide. If you want to know more about this EN-LoTIS working group and what we're doing going forward, please contact me. Thank you.